Welcome to Fantastic Stories. The origin of life on Earth is one of the most profound and complex questions in science. Several theories have been proposed to explain how life began on our planet, each with its own set of hypotheses and supporting evidence. How did life on Earth begin? Abiogenesis. Abiogenesis is the most widely accepted scientific theory for the origin of life. It posits that life arose naturally from non-living matter through a series of chemical reactions that occurred on Earth's early environment. Primordial soup theory suggests that the Earth's early oceans were rich in organic molecules, which were the building blocks of life. Energy sources like lightning, UV radiation, or volcanic activity could have triggered chemical reactions, leading to the formation of simple organic compounds, which eventually become complex and led to the first living cells. A famous experiment simulated the conditions of early Earth and demonstrated that organic molecules, like amino acids, the building blocks of proteins, could be synthesized from simple inorganic precursors under prebiotic conditions. This provided experimental support for the primordial soup hypothesis. Hydrothermal vent hypothesis. This theory suggests that life may have originated at hydrothermal vents on the ocean floor. Hydrothermal vents are fissures on the ocean floor where the heated water, rich in minerals, flows from beneath the Earth's crust. The extreme conditions, including the presence of chemical energy sources like hydrogen sulfide, may have provided the rich environment for the formation of complex organic molecules and the first life forms. Alkaline hydrothermal vents, which have a high pH and are rich in minerals like iron and sulfur, could have provided the rich conditions for life to begin. The natural proton gradients found in these environments could have driven the formation of energy-rich molecules, setting the stage for the development of primitive life forms. Deep sea alkaline hydrothermal vent hypothesis. This variation of the hydrothermal vent hypothesis emphasizes the role of alkaline hydrothermal vents, which have a high pH, are rich in minerals like sulfur and iron, and produce naturally occurring proton gradients that some scientists believe could have powered early biochemical reactions. In these vents, the difference in pH between the acidic ocean water and the alkaline vent fluids could have created natural proton gradients similar to those used by modern cells to generate energy. This could have been a precursor to the development of life's metabolic processes. RNA world hypothesis. This theory suggests that RNA, a molecule similar to DNA, was the first genetic material which played a crucial role in the origin of life. Self-replicating RNA. RNA is capable of both storing genetic information and catalyzing chemical reactions. The RNA world hypothesis proposes that early life was based on RNA molecules that could replicate themselves and catalyze their own reactions, leading to the evolution of complex molecules like DNA and proteins. Ribozymes. RNA molecules that can act as enzymes, known as ribozymes, support this hypothesis. The discovery of ribosomes provided evidence that RNA could indeed catalyze reactions necessary for life, such as the replication of genetic material. Iron-sulfur world hypothesis. This theory suggests that life may have originated on the surfaces of iron and nickel sulfide minerals. Surface metabolism. The hypothesis proposes that the first metabolic processes occurred on the surface of these minerals, which acted as catalysts for chemical reactions. The interaction of these minerals with carbon dioxide and hydrogen could have led to the formation of organic molecules, eventually leading to the development of early life forms. Mineral surfaces as catalysts. The theory emphasizes that life could have started as a series of surface-catalyzed reactions rather than a soup of organic molecules. These reactions could have provided a steady supply of energy and the building blocks needed for life to begin. Panspermia. Panspermia is the idea that life on Earth did not originate here, but was instead brought from elsewhere in the universe. Lithopanspermia. Life could have been carried to Earth on meteorites, comets, or other celestial bodies after originating elsewhere in the solar system or even beyond. Some microorganisms are known to be incredibly resilient and could potentially survive the harsh conditions of space and re-entry into Earth's atmosphere. Directed panspermia. This variation suggests that life was intentionally seeded on Earth by an advanced extraterrestrial civilization. While speculative, it remains a part of the broader panspermia hypothesis. Clay hypothesis. This theory suggests that complex organic molecules might have first formed on the surfaces of clay minerals. clay as a catalyst. Clay minerals can absorb organic molecules and catalyze chemical reactions. This theory posits that the first life forms could have arisen from the interaction of organic molecules on the surfaces of clay, where they could have assembled into more complex structures like RNA and proteins. Template theory. The idea is that clay provided a template for the assembly of the first organic molecules, which later evolved into more complex life forms. In conclusion, the origin of life on Earth is still a subject of intense research and debate. While the abiogenesis and RNA world hypotheses are currently the most widely supported by the scientific community, the other hypotheses offer compelling alternative explanations. The panspermia hypothesis, though more speculative, remains an intriguing possibility, particularly in the context of understanding life beyond Earth. Each of these theories contributes to our understanding of how life might have begun and evolved into complex biosphere we see today. Thank you for watching. If you enjoyed the story, consider subscribing to my channel. Have a great day and see you next time.